June 19, 2026, 1:47 a.m. 43 modified Liutyi drones are already airborne over Ukrainian territory, climbing through darkness toward coordinates 600 kilometers to the east. Their targets are not trenches, not forward operating bases, not armor columns moving under cover of night. Their targets are the compression halls, separator arrays, and pressure nodes deep inside the Orenburg gas processing plant, one of the largest natural gas facilities on the Russian mainland. Within 6 hours of the first impact, 3 federal grid zones will lose pressure below operational threshold. Within 72 hours, industrial heating across 4 Russian oblasts will be running on emergency reserves, burning through stockpiles that were never meant to sustain a crisis of this scale. This is not a battlefield strike in the conventional sense. It is precision industrial surgery, performed from 600 kilometers away, guided by months of satellite analysis, maintenance cycle mapping, and intelligence work that reached inside the operational schedules of a Russian energy facility most Western analysts had never considered a military target. Ukraine's general staff has spent years developing the doctrine for exactly this kind of operation: deep strikes against the economic infrastructure that sustains Russian military logistics, fuels its forward bases, and insulates its population from the consequences of a war their government tells them is going smoothly. Tonight, that doctrine faces its most ambitious test yet. I'm your host at Steelfront, where we analyze the battles that change wars. What we're about to walk through is not just a drone strike story. It is a case study in how a smaller military, denied the ability to fight on equal terms, reaches deep into enemy territory and disables systems that no amount of frontline manpower can replace. The Orenburg plant was not a symbolic target. It was a calculated one. And by the time Russian emergency crews understood what had happened, the damage was already irreversible for the near term. How Ukraine identified that 40-minute window of vulnerability, how they structured the strike package to exploit it, and what it cost Russia across the following 72 hours. That is what we are here to break down tonight. Let's go back to the beginning. The Orenburg gas processing plant sits in the southern Ural region of Russia, a sprawling industrial complex that processes natural gas extracted from the Orenburg field, one of the largest in Russian history, discovered in the 1960s and developed through the Soviet era into a cornerstone of domestic energy supply. By 2026, the plant feeds gas through a network of pipelines into 3 federal grid zones, serving Moscow, the central industrial belt, and portions of the Volga region. It is not primarily an export facility. It is a domestic pressure node, the kind of infrastructure that, when disrupted, creates cascading failures through heating systems, industrial boilers, and manufacturing processes across hundreds of kilometers of downstream pipeline. For Ukrainian GUR, the main Directorate of Intelligence, this distinction mattered enormously. Export infrastructure, particularly pipelines moving gas toward Europe, carried diplomatic complications even in wartime. Domestic infrastructure, feeding Russian military logistics and industrial production, was a different category entirely. And by late 2025, GUR analysts had identified something specific about Orenburg. A significant portion of the plant's processed gas output was being diverted through a secondary pipeline network to Russian forward logistics bases along the southern front, not the main export trunk lines. A secondary network, running south and southwest, supplying fuel to field kitchens, vehicle maintenance facilities, and heating systems at staging areas used by Russian forces operating in the Zaporizhia and Kherson sectors. That made Orenburg, in GUR's assessment, a legitimate military logistics target. Which weapon system would you trust to hit a target 600 kilometers from the launch point, at night, through layered Russian air defense coverage, against a facility whose operators had never considered themselves a strike target? HIMARS with long-range munitions? Storm Shadow cruise missiles? Or a purpose-modified Liutyi strike drone, slower than a missile but far more numerous, cheaper to build, and capable of saturation tactics that overwhelm point defenses? Comment below with your read on the optimal deep strike package for a target at this range. The Liutyi, translated roughly as fierce or ferocious, is Ukraine's domestically developed long-range strike drone, an evolution of earlier designs that incorporated lessons from 2+ years of deep strike operations. By mid-2026, the production variant being deployed had extended its range beyond 600 kilometers through fuel efficiency improvements and lightweight composite airframe redesign. It carries a shaped charge warhead optimized for industrial targets, not armor-piercing, but designed to rupture pressure vessels, compromise compressor housings, and ignite gas-handling equipment in ways that create secondary damage far beyond the initial impact point. GUR had been studying the Orenburg plant for over 8 months before June 2026. The intelligence collection effort involved multiple streams: commercial satellite imagery cross-referenced against Russian maintenance scheduling documents, obtained through human intelligence networks, signals intercepts from plant administrative communications, and analysis of thermal satellite data showing the operational cycle of the compression halls. What that analysis revealed was a pattern, not a flaw exactly, but a window created by the intersection of the plant's overnight maintenance rotation and the operational limits of its thermal perimeter detection systems. The plant ran 3 compression halls in standard operations. 2 handled the primary processing load during peak hours. The third operated as backup capacity and underwent routine maintenance on a rotating schedule. The overnight maintenance window, typically running from roughly 1:30 a.m. to 2:10 a.m. local time, saw Compression Hall 2 taken partially offline for sensor calibration and equipment checks. During this window, the thermal perimeter detection coverage around the northwestern approach to the compression hub had a gap. Not a complete gap, but a reduction in sensor density that, combined with the noise floor created by ongoing operations in halls 1 and 3, created approximately 40 minutes where the northwestern approach was detectably less monitored than at any other point in the daily cycle. That 40-minute window was the key to everything. But here is where the operation nearly came apart before it started. 3 weeks before the June 19 strike date, GUR's satellite analysis team identified something that had not been in their intelligence picture. Russia had installed an additional mobile air defense unit, believed to be a Pantsir S-1 system, at a position approximately 12 kilometers northeast of the plant perimeter. The new deployment changed the threat geometry for any strike package approaching from the east or northeast, which had been the originally planned ingress route for the first drone wave. The mission planners had a choice: delay and recollect intelligence on the new air defense positioning, or redesign the strike package geometry around the changed threat environment. Delaying risked losing the operational window. Maintenance rotation schedules at the plant could change. The seasonal thermal patterns that created the detection gap would shift as summer progressed. And the longer the planning process ran, the greater the risk of intelligence compromise. They chose to redesign. The revised plan split the 43 drones into 2 distinct waves with different ingress routes and different timing. The first wave, 21 drones, would approach from the eastern corridor, which now faced the Pantsir coverage. But these 21 were not carrying strike warheads. They were flying a saturation and deception role, drawing Russian air defense attention toward the eastern perimeter, forcing the Pantsir crews into engagement mode, burning through their reload cycle and saturating the radar picture with tracking contacts. Their job was not to hit the plant. Their job was to make the air defense network look east. The second wave, 22 drones carrying the actual strike warheads, would approach from the northwest. Slower, lower, using terrain masking from the Ural foothills to stay below radar coverage as long as possible. Timing their arrival at the target perimeter for the 40-minute window when the compression hub's own detection systems were at their lowest sensitivity. The geometry was elegant. The execution risk was enormous. Stay with me. What unfolds in the next 18 minutes of this operation determines whether 43 drones change the energy calculus of the Russian war machine, or whether they become expensive wreckage in a Russian field, and a planning failure that sets Ukraine's deep strike program back by months. The launch sequence began at 10:23 p.m. on June 18th, local time. The drones did not launch from a single location. Ukraine's deep strike operations have, through hard experience, learned that concentrated launch sites are themselves targets. Russian reconnaissance assets watch for the thermal and radar signatures of mass drone launches, and a single successful Russian strike on a launch site can abort an entire mission package. The Liutyi units were deployed from 3 separate launch positions across a roughly 60-kilometer arc, staggered in timing by 11 minutes to prevent their radar returns from merging into a single identifiable signature during initial climb. The first wave took approximately 3 hours and 20 minutes to reach the target area. The drones flew at altitudes designed to minimize their radar cross-section, low enough to use terrain masking where available, high enough to avoid obstacles in the dark, navigating through a combination of preloaded GPS waypoints and terrain-following algorithms, updated with the most recent digital elevation model data available to GUR planners. Russian air defense networks along the ingress route registered some contacts. Several decoy wave drones were engaged and brought down during the approach phase. Ukrainian mission planners had anticipated a loss rate of approximately 25 to 30% on the decoy wave, and had sized the package accordingly. The second wave, flying the northwestern corridor, encountered lighter detection and engagement pressure during approach. The terrain masking worked. The lower altitude profile reduced the window in which Russian ground radar systems could acquire and track them. By 1:31 a.m. local time on June 19th, the second wave drones were within 40 kilometers of the Orenburg plant perimeter and still unengaged. At 1:43 a.m., the first wave drones began arriving at the eastern plant perimeter, triggering the plant's own security systems and drawing attention from Russian air defense elements in the area. The Pantsir unit northeast of the facility went active, tracking and engaging. Plant security personnel began their emergency protocols, evacuation warnings, shutdown initiation sequences for the most sensitive systems. Russian emergency services were alerted. The eastern perimeter became the crisis point. How many processing systems did Ukrainian drones successfully disable in the Orenburg strike? A. 14 primary compression units. B. 2 compression halls plus 4 primary separator arrays. C. The entire compression hub plus auxiliary control systems. The answer comes at the end. Stay with us. At 1:47 a.m., exactly when the first wave engagement was peaking and Russian attention was locked on the eastern approach, the second wave crossed the plant's northwestern fence line. 22 Liutyi drones, each carrying a shaped charge warhead optimized for industrial pressure systems, dropped to their terminal attack altitude and acquired targets from their preloaded strike packages. The compression hub, 2 interconnected buildings housing the primary compression machinery for the entire plant's output, was the priority target. GUR planners had identified the specific buildings through satellite imagery cross-referenced with publicly available engineering documentation from the plant's Soviet-era construction records. The compressor housing geometry, the location of primary pressure vessels, the positioning of electrical control systems for the compression arrays, all of it mapped, loaded, and waiting. The drones did not arrive simultaneously. The strike was sequenced in 3 subwaves within the second package, arriving at 90-second intervals. The first 6 drones hit the northwestern wall of Compression Hall 1, their warheads optimized to breach the building structure and expose the internal equipment to the subsequent arrivals. The next 8 targeted the compression machinery directly: pressure vessels, compressor housings, the interconnected pipe manifolds that linked the 2 compression halls into a unified pressure system. The final 8 targeted the electrical control infrastructure, the switchgear rooms, the automated control systems, the backup power feeds that kept the compression monitoring systems online. In approximately 4 minutes, the Orenburg plant's compression hub went from a functioning industrial installation to a burning, pressure-venting wreck. Russian plant operators who had been managing the crisis on the eastern perimeter now faced simultaneous catastrophic failures on the western side. Pressure warnings cascading across monitoring systems, automatic shutdown protocols triggering in sequence, and fire suppression systems activating in buildings that were no longer structurally intact enough for those systems to function as designed. What this operation reveals is not just tactical competence. It shows where Ukraine's deep strike doctrine has arrived by mid-2026. This is not improvised. This is not desperation. This is a mature operational framework built over years of painful trial and error. integrating intelligence collection, target analysis, strike package design, and electronic deception into a single coherent mission architecture. Most militaries with Ukraine's resource constraints cannot execute this. Ukraine can, because Ukraine has spent 3 years developing exactly these capabilities under the pressure of a survival war. Put yourself in the position of the GUR mission planner who redesigned the ingress geometry 3 weeks before the strike when that new Pantsir unit showed up in the satellite imagery. You have an operation 8 months in the making, a target window that will not hold indefinitely, and a change in the threat environment that invalidates your approved strike plan. What do? Most institutional military planning processes would push the decision upward, delay for committee review, wait for a new intelligence cycle. GUR's planners made the call and redesigned. That decision is why 43 drones hit their targets instead of sitting in hangars while a committee deliberated. By 2 a.m. on June 19th, approximately 13 minutes after the second wave's first impacts, Russian emergency response vehicles were beginning to arrive at the plant. But the nature of the damage created an immediate problem for responders. The breached pressure vessels were still venting natural gas into the compression hull structures. Emergency crews could not enter safely until the remaining pressure in the affected pipe sections had been bled down through manual valve closures, a process that took approximately 40 minutes under emergency conditions, and that required plant personnel who were simultaneously trying to manage the automated shutdown sequences cascading through the facility's control systems. Russian emergency services did what they could, but the damage had been designed to prevent rapid restoration. Destroying compression machinery is one thing. Compressors can be replaced, though not quickly. The strike on the electrical control infrastructure was the slower-acting but more decisive blow. The automated control systems for the compression arrays were gone. Running a gas processing facility without automated pressure monitoring and control is extremely difficult to do safely at scale, and Russian plant operators faced the choice of either attempting manual operation of surviving systems, with all the accident risk that implies, or keeping the facility in shutdown until control systems could be restored or replaced. They chose shutdown. The downstream consequences moved faster than Russian emergency planners had modeled. The Orenburg plant feeds into a pipeline network whose pressure is maintained by the continuous operation of the compression systems. When compression stops, pressure upstream of the facility builds. That is manageable. But pressure downstream begins dropping as consuming systems draw from the pipeline without replenishment. The rate of pressure drop depends on how much gas is in the downstream pipeline system and how fast it is being consumed. June 19 was not a cold night across the Russian central industrial belt, but industrial consumers, manufacturing facilities, chemical plants, power generation stations running gas turbines, operate continuously regardless of ambient temperature. Their consumption does not vary with season, and their gas supply, drawing from the Orenburg node, began losing pressure within 90 minutes of the plant's compression system going offline. By 4:30 a.m., downstream pressure in the first of 3 affected federal grid zones had fallen below the operational threshold for sustained industrial consumption. Automatic safety systems at industrial facilities began triggering, burner management systems shutting down gas-fired boilers when fuel pressure fell below minimum operating requirements, turbine protection systems taking gas-fired generation units offline. By 6:17 a.m., 6 hours after the first Liutyi impacts, all 3 downstream grid zones had lost pressure below operational threshold, and cascading industrial shutdowns were triggering across 4 Russian federal oblasts. Here is an unpopular opinion, and we will stand behind it. Russia's decision to link military logistics supply lines to civilian domestic energy infrastructure was not just a military planning failure. It was a deliberate political calculation that treated civilian industrial capacity as a buffer against the consequences of military vulnerability. When GUR confirmed that the Orenburg plant was supplying processed gas to forward logistics bases along the southern front, they were not discovering an accident of geography. They were discovering a Russian logistics doctrine that deliberately entangled military and civilian infrastructure as a deterrent against targeting. Ukraine's planners concluded that the entanglement does not make the military target immune, it makes the civilian consequences Russia's responsibility. We think that call was right. It will not be a popular view in every capital, but the evidence supports it. Here is what the evidence also shows. The secondary pipeline network from Orenburg to Southern Front logistics bases ran offline within 4 hours of the main plant shutdown. Ukrainian General Staff assessments, citing drone surveillance of the affected forward supply areas conducted in the days following the strike, reported that at least 6 logistics facilities supporting Russian units in the Zaporizhia sector showed thermal signatures consistent with emergency generator operation, meaning their primary heating and power systems had failed, and backup generators were compensating. Emergency generator fuel consumption at that scale has its own logistics tail. Russia was now burning diesel reserves at forward positions to compensate for gas supply disruption, and those diesel reserves are not unlimited. Subscribe to Steelfront if you want to understand how modern warfare actually works. Because what we're describing here is not an isolated strike. It is one operation in a systematic campaign to strangle the logistics and energy infrastructure that sustains Russian military operations. And the strategic architecture behind it matters as much as the tactical execution. Moscow's official response came within hours of the strike becoming public knowledge through social media and Russian Telegram channels, which had begun posting plant security camera footage and emergency response video before any official statement was issued. The Kremlin's spokesperson condemned what it called a deliberate attack on civilian energy infrastructure, characterizing the strike as terrorism and pledging retaliation against Ukrainian energy systems. The language was familiar. Russia has applied the terrorism label to virtually every Ukrainian deep strike against infrastructure since 2022, while simultaneously conducting massive missile and drone campaigns against Ukrainian civilian power generation, heating infrastructure, and water systems. Ukrainian officials issued no formal statement on the Orenburg operation. This has become standard practice for Ukraine's deep strike program. Deniability maintained through silence, confirmation provided only through GUR-adjacent Ukrainian media sourcing, and the physical evidence visible in Russian social media. A source described only as a GUR official, cited in a Ukrainian outlet on June 20th, confirmed that the plant had been supplying fuel to Russian forward logistics bases and characterized the strike as a legitimate military operation against supply chain infrastructure. That was the extent of official Ukrainian acknowledgement. The question that matters here is not the diplomatic framing, it is the military effectiveness assessment. Going through the available OSINT record on this operation, the satellite imagery that began appearing from commercial providers in the 48 hours after the strike, the thermal data showing the plant's operational status, the downstream pressure reports that leaked from Russian regional energy management systems into public channels, and the pattern of industrial shutdown events reported in Russian regional media over the following days, one detail kept coming back as the clearest indicator of how decisive the damage was. The Russian Energy Ministry, in its own public statements about the incident, never put a timeline on restoration. The standard language for infrastructure incidents, restoration expected within X hours, or operations resuming on Y date, was conspicuously absent. They spoke of assessment and repair operations ongoing, without any schedule. That language, in the vocabulary of industrial emergency management, means the damage was worse than initial estimates. It means the teams on the ground were finding problems they had not anticipated from the initial reports. It means the 43 Liutyi drones had done more than disrupt a facility. They had fundamentally compromised its operational integrity in ways that required not just repair, but partial reconstruction. Full pressure restoration to all 3 downstream grid zones took 72 hours. Some industrial facilities that had shut down automatically during the pressure loss event required additional time to safely restart. Gas-fired industrial systems cannot simply be turned back on when pressure returns. They require inspection, purging, and controlled restart sequences. Several facilities in the affected oblasts were reported by Russian regional outlets to have remained offline for between 4 and 6 days after the initial event. The comprehensive damage assessment, compiled from satellite imagery, OSINT analysis, and Ukrainian intelligence estimates, pointed to the following. Both primary compression halls sustained severe internal damage, requiring major equipment replacement. 4 of 6 primary separator arrays in the main processing train were destroyed or critically damaged. The automated control infrastructure for the compression and separator systems required complete replacement. Estimated restoration time for full operational capacity, based on equipment procurement and installation lead times for specialized industrial compression machinery, was assessed at between 4 and 7 months, with the lower end of that range requiring Russia to successfully source replacement equipment under sanctions pressure. That last point carries weight that numbers alone do not convey. Russia's industrial equipment sanctions situation, by mid-2026, had materially degraded its ability to quickly source and install specialized Western-manufactured industrial compression systems. Much of the equipment in facilities like Orenburg was installed during the Soviet period, or in the post-Soviet decade, when Western industrial equipment was freely available. Replacement parts and modern equivalents increasingly have to be sourced through third-party intermediaries, at significantly inflated cost, and with uncertain delivery timelines. Ukraine did not just destroy Russian infrastructure. Ukraine created a procurement and logistics problem for Russia's sanctioned industrial complex that cascades for months. What would NATO have done differently against a target of this type? At this range, with this strategic objective? Comment your analysis. We're curious whether you think the saturation and deception approach was optimal, or whether a different strike architecture could have achieved the same result with fewer assets. The operational lesson from the Orenburg strike is this. Modern warfare's decisive engagements are increasingly not on the front line. They are 600 kilometers behind it. The ability to reach that deep, strike with precision, and create damage that takes months to repair is what separates a tactical military operation from a strategic one. Ukraine's Liutyi program, and the GR intelligence architecture that enables it, is exactly this kind of strategic strike capability, built indigenously, under wartime conditions, against a backdrop of resource constraints that would have stopped most military establishments from attempting the development program at all. The Orenburg strike did not end the war. Nothing ends this war in a single operation, but it demonstrated, with evidence that Russian Energy Ministry officials cannot explain away through press releases, that Ukraine's reach now extends to the infrastructure backbone of Russian domestic industrial capacity. Every Russian facility planner, every logistics officer, every Energy Ministry administrator now has to account for Ukrainian strike capability in their contingency planning. That is a strategic burden Russia has to carry. And strategic burdens accumulate. One detail in this operation has stayed with me through all the analysis. The 40-minute window, 8 months of intelligence collection, satellite analysis, signals intercepts, and maintenance schedule mapping. All of it to identify a single 40-minute gap in detection coverage around one section of one facility's perimeter. That is the level of analytical investment Ukraine's intelligence services are now capable of bringing to a single operational target. When people ask whether Ukraine can sustain a deep strike campaign against Russian infrastructure over the long term, this is the evidence I point to, not the drones themselves, the doctrine, the patience, and the analytical precision behind them. That is what turns 43 drones into a 72-hour national energy crisis for Russia. Will Ukraine execute a comparable deep strike operation against Russian energy infrastructure within the next 60 days? Drop yes or no in the comments. We read every one. Now, the quiz answer from earlier in this video. How many processing systems did Ukrainian drones successfully disable in the Orenburg strike? The answer is B. 2 compression halls plus 4 primary separator arrays. The decoy wave successfully drew Russian air defense engagement on the eastern perimeter, allowing the second strike wave to penetrate the northwestern approach and execute against the compression hub and separator train with high precision. The electrical control infrastructure strikes are assessed as the most strategically significant component. Even if Russia had been able to physically repair the compression machinery faster, the destruction of the automated control systems extended the restoration timeline by weeks. The complete loss of 14 primary compression units, option A, was not achieved because not all compression units within the two halls were fully destroyed. Some sustained damage that degraded rather than eliminated their function. The full hub plus auxiliaries, option C, overstates the damage to the auxiliary control systems, which were partially restored within the first 72 hours. Option B accurately reflects the confirmed damage picture from satellite and OSINT analysis. 3 questions that should stay with you after this analysis. Was the decision to proceed with the strike despite the newly identified Pantsir deployment the right call? The redesigned strike package worked, but if the second wave had been detected and engaged during the northwestern approach, the entire 8-month operation would have produced nothing but losses. The risk calculus was real, and reasonable people could argue that delaying for a full reassessment was the more conservative and defensible choice. Could Russia have prevented this with better integrated air defense around critical infrastructure? The Pantsir edition 3 weeks before the strike suggests Russian planners were aware of some vulnerability, but the coverage gap was created by the plant's own maintenance schedule and thermal detection limitations, not purely by air defense positioning. A more comprehensive defense-in-depth architecture around a facility of Orenburg's strategic importance could have made the second wave's northwestern approach significantly more dangerous. What would you have done differently if you were the GUR planner who had to redesign the strike geometry in 3 weeks with a target window that couldn't wait indefinitely? Subscribe to Steelfront, because we break down the battles that textbooks will study for decades. The Orenburg plant is quiet now. Emergency repair crews have worked the site for days. The burning has stopped. The venting gas has been sealed. But 2 compression halls are gutted, 4 separator arrays are wreckage, and the automated control systems that kept this facility running through every season of Russia's war are gone. Somewhere in those ruins is the evidence of a 40-minute window that 8 months of intelligence work identified and 43 drones exploited in the dark hours of a June morning. Silent testimony that modern warfare punishes strategic vulnerabilities without mercy, whether those vulnerabilities are found on a frontline trench or inside a gas processing plant 600 kilometers from the fight. Real tactics, real consequences. Steel Front.